I would like to focus on one relationship that almost every manufacturing company struggles with: engineering and procurement. Whether it is aerospace, semiconductors, chemical development, raw materials development, civil engineering, just name any manufacturing company, any company that produces something. There's always a struggle between engineering and procurement, and that's a fact. That's a proven fact. At first glance, these two functions appear to have completely different jobs. Engineering asks, what should we build? Procurement asks, how do we obtain what engineering needs? It's simple. But between those two questions lies one of the biggest sources of delay in modern manufacturing. Let's begin on the left. Engineering defines requirements. It develops designs, selects materials, performs analysis. It produces design changes. Continuously, it improves the product. Engineering is constantly learning. And because engineering is constantly learning, requirements continue evolving. That is completely normal. And in fact, if engineering never changed the design, I would be worried. Continuous improvement is exactly what engineering should do. Now, move over to procurement. Procurement has a very different responsibility. It must identify suppliers, require quotations, compare technical capability, negotiate commercial terms, manage contractual risks, issue purchase orders. Everything procurement does is designed to create certainty. Engineering creates change. Procurement creates stability. Neither objective is wrong, never, but they naturally pull in different directions. Now let's look at the middle. This is where things become interesting. Engineering doesn't simply hand work to procurement. It hands over information, requirements, specifications, volumes, drawings, lead time expectations, etc., certification constraints, supplier preferences, commercial assumptions. Every one of those become an input to procurement's work. If that information is incomplete, late, or continuously changing, procurement cannot make confident decisions. One of the biggest challenges I observed inside aerospace is that procurement rarely receives early visibility. Instead, procurement often waits. It waits for engineering to complete enough analysis. It waits for approvals. It waits for drawings. It waits for authorization, and only then does sourcing begin. That means procurement becomes reactive rather than proactive, not because procurement lacks capability, but because it lacks visibility. And then, of course, bureaucracy begins to multiply. Engineering requests clarification. Procurement requests clarification. Quality requests clarification. Legal reviews, contracts, program management update schedules. Approvals move through multiple organizational layers. Everyone is trying to reduce risk, and ironically, the cumulative effect is riskier. It often becomes more delay. Eventually, work actually simply stops moving. Notice the entire center of the diagram. Engineering doesn't say engineering failed. It doesn't say procurement failed. It says work does not flow forward. That's an important distinction. The problem isn't people. The problem is flow. Now think about what happens next. Suppliers are engaged later than they should be. Quotations become rushed. Engineering continues changing designs. Schedules begin slipping. Premium freight appears. Manufacturing starts waiting for materials. Production lines become starved. Customers receive late deliveries. Margins begin shrinking. Notice something, that the financial impact appears at the very end. So by the time finance is able to get their metrics and show it to the executives, the delay actually began much earlier. It's already too late by the time the metrics are at the hands of the finance department. This is one reason why manufacturing companies often believe that they have a production problem, but in reality, they have an information problem. Factories cannot build components that haven't been sourced. Suppliers cannot manufacture parts for requirements that haven't received. Procurement cannot negotiate contracts for specifications that are still changing. Everything downstream simply waits. Now look over to the right side. I have listed 10 reasons this interface becomes so difficult. Look here. Siloed objectives, late procurement involvement, incomplete requirements, different digital systems in the same company, poor forecasting, complex specifications, risk-averse decision-making, limited supplier collaboration, weak change management, global time zones. Notice something, that very few of these are actually technical problems. Almost all of them are coordination problems. And that is the problem. That is the problem, that in an engineering company, manufacturing companies, the leadership, they're all engineers and they all want, I was one of them as well, I must admit, we all wanted glory for the next technical advancement. We all want to build the next Nobel Prize winning technology out there. But then that does not always add value. What adds value, mitigating these risks out here, factors that actually smoothen the collaboration, because the smoother the collaboration between an organization, the healthier is the organization, the less risk it is for the organization to collapse at one point, and therefore the stock prices and the value of the organization is generally increasing higher. That's why Silk Route of System focuses on the fact that enterprise architecture or an enterprise intelligence platform that we provide is a capital asset for a company. It compounds in value. So what does good collaboration looks like? It starts much earlier. Procurement joins the conversation while engineering is still defining requirements. Both functions share the same data. They share priorities. They share forecasts. Suppliers become partners rather than emergency responders. Decisions become faster because everyone is looking at the same information. Instead of handing work across organizational walls, they build the solution together. And this brings us to what I believe is one of the most overlooked causes of stagnant profitability in manufacturing. Executives often focus on reducing labor costs, negotiating supplier prices, increasing factory utilization. Those certainly matter, but none of them can compensate for a broken flow of information. Because every day lost before procurement engages becomes multiple days of lost inside manufacturing. Every day manufacturing waits becomes delayed customer deliveries, higher logistics costs, premium freight, contract penalties, and ultimately lower profit margins. That is why I don't see this as an engineering problem or a procurement problem. It's always an architecture problem, because architecture is responsible for ensuring that the right information reaches the right people at the right time with enough visibility for decisions to move forward instead of waiting. When that happens, something remarkable changes. Production does not simply become faster. The entire enterprise begins flowing as one connected system. And that is where operational excellence truly begins. This slide is about value. How is value created and how value moves and where value quietly dies. Let's start on the far left. Everything begins with commercial. Commercial doesn't manufacture aircraft. Commercial doesn't design aircraft. Commercial makes promises. Promises to customers, delivery dates, performance guarantees, contractual obligations, liquidated damages, margins, revenue, future businesses. Commercial creates commitments. Those commitments become reality only if the rest of the organization can actually execute them. And that's where the journey begins. Commercial hands those commitments to engineering. Engineering now has to translate business language into technical language. Contracts become requirements. Requirements become architectures. Architectures become designs. Designs become analysis. Analysis become drawings, and drawings become certifications. Engineering is essentially translating commercial intent into something physics will allow. Eventually, engineering finishes, or at least it reaches a point where manufacturing can begin. At least that's how the flow should work. But look at the middle of the slide. This isn't called the engineering department. It's not the procurement or manufacturing. It's the disconnect zone right here, the disconnect zone. And I think this is one of the most important phases in this entire presentation, because this is where organizations quietly lose millions, not through spectacular failures, not through tiny delays, tiny misunderstandings, tiny approvals, tiny handovers, but thousands of them every month and every year. Look at what's happening here. Different KPI, different objectives, late information, incomplete information, too many approvals, systems that don't communicate, no clear ownership, communication breaks down, change propagates slowly but through the organization, and none of these changes propagating slowly through the organization, but none of these individually destroy a program, but together, because they happen parallelly, obviously, they always suffocate the results. They suffocate value. They suffocate people. Here is something fascinating. Nothing physical has happened yet. No aircraft has been built. No supplier has failed. No production line has stopped. Nothing has exploded. And yet the delay has already begun because the information has stopped flowing. Manufacturing is probably the most visible function in any aerospace company. Aircraft parts arrive. Manufacturing right here. Aircraft parts arrive, machines operate, people assemble, quality inspects, products ship, customers receive. But manufacturing is the last domino. It simply inherits everything that has happened upstream. Manufacturing rarely creates delay. Manufacturing reveals delay. If information arrives late, materials arrive late. If materials arrive late, production waits. If production waits, delivery slips. If delivery slips, customers wait. And if customers wait, profit disappears. Manufacturing simply exposes what already happened months earlier. Now look here. Look across the bottom here. This may be the most important sentence on the slide. Every delay upstream compounds downstream. That single sentence explains why so many executive meetings focus on the wrong place. Executives often see late delivery. Factories see missing parts. Program managers see missed milestones. Finance sees reduced margins. Customers see broken promises. But all of them are just looking at symptoms, not causes. That cause began much earlier when information stopped flowing. Now let's look at the 18 factors on the right side here. These 18 factors. Very few of them are engineering problems. Very few are manufacturing problems. Most are organizational problems. Contract language isn't decomposed. Procurement joins too late. Engineering changes continue. KPIs compete instead of align. Approval chains become longer. Systems don't communicate. No single owner exists. And committee decisions replace accountable decisions. Every one of these introduces another layer of latency. It's almost like adding another traffic light to a motorway. Eventually, everything moves, but nothing flows. Now, compare that with the bottom of the slide. What does good collaboration actually look like? Early alignment, one digital thread, joint planning. Look here. Early alignment, one digital thread, joint planning, open communication, agile decisions, supplier partnerships. Notice what isn't listed. It's artificial intelligence, blockchain, digital twins, cloud platforms, because none of those things solve the problem by themselves. No, it does not. Technology amplifies architecture. It doesn't replace architecture. If the architecture is fragmented, digital tools simply allow fragmentation to happen faster and to even crystallize into losses. So what is the solution? Integrated processes, connected systems, clear ownership, real-time visibility, shared governance, one flow. Not because integration sounds elegant, but because every organization already has one value stream, whether it recognizes it or not. This is the real insight I took away from my time inside GKN Aerospace. The company does not lack brilliant engineers. It lacks continuous visibility of value as it moves through the organization. Today, every department optimizes its own piece of the puzzle. Commercial optimizes contracts, engineering optimizes design, procurement optimizes supplier cost, manufacturing optimizes throughput, finance optimizes cash. Each function becomes exceptionally good at its own objective, and yet the enterprise can still become slower because nobody is continuously optimizing the flow between them. And this is the story of every aerospace company out there and many, many, many capital equipment companies out there. It's more likely than not, if you are a multinational organization, the flow of information in your company is fragmented. And it's okay to admit that. And it's okay to seek help. The central idea behind everything I have presented is that enterprise architecture isn't about drawing organizational charts. It's not about governance documents. It's not about selling you a software. I don't have any software to sell, by the way. It's about making value visible, because once value becomes visible, the bottlenecks become visible. The ownership becomes visible. And when that happens, decisions become faster. and delivery becomes more predictable. Customers become happier, margins improve naturally, and not because people worked harder, but because the organization finally began behaving like a single system instead of a collection of different departments or different companies.